Okay, question 3. This is the first question about a required practical. This is about the specific heat capacity required practical. It is possible that when you did this, in fact probable that when you did this practical, you did not use an aluminium block. What you used was water with a heating coil. However, you would have been shown this setup, and in all of the revision guides they use this particular setup. So, 3 marks. So, 1 mark, an aluminium block, okay? And you might put, there are 2 holes in the aluminium block. And you might even say that it's 1 kilogram of aluminium. Okay, you have a thermometer. And a heater. Okay, this is 2 marks. So we got something to heat it up, something to measure the temperature change, the aluminium block that you're heating up, and the best thing is a joule meter and a power supply. Okay. The other option instead of a joule meter is you need a stopwatch and a ammeter and voltmeter connected properly. Okay? You cannot get away with just an ammeter because the power supply voltage that you set it to is not the actual voltage that the heater is necessarily using. Okay? It's usually a little bit less. Okay? Because these are not ideal power supplies, they are real power supplies. So, that was your 3 marks. Aluminium, thermometer, and heater, and a joule meter. Okay? The alternative to the joule meter is an ammeter and voltmeter with a stopwatch. Okay? Okay, so here's the first 6-mark question. Describe how you could use the apparatus you drew to determine the specific heat capacity of aluminium. So, obviously some of the marks come from how you explain it and how you do it, but I'm just going to point form this out. So, number 1, you need to, yes, set up the apparatus as shown. Okay. Record the starting temperature. Turn on the heater. Okay. You could, then you need to record the temperature. And energy. Let's say every 1 minute for 10 minutes. Okay? Then what you need to do is plot the results. You would have temperature versus energy. Okay, and then specific heat capacity is the gradient of is the gradient of the straight line part of the graph, because your graph should have a shape something like this. and then it goes straight. So it should have a curve, and then it would be straight. So the gradient of this part divided by the mass. Okay, so you need to divide it by the mass of aluminum. Which means that actually I should have somewhere up here measure the mass of with a balance. Okay, so I mean that's the basic thing. So we have to record a starting temperature, we have to turn on a heater, we record a temperature and the energy used every minute for 10 minutes. You need to plot the results of temperature versus energy. And then your specific heat capacity is the gradient of the straight part of the graph divided by the mass of aluminium. Okay? You could add in that you were going to do repeats, but I mean, with this it would take forever. You would have to calculate energy from your voltmeter and ammeter. So you would need to have, so if you used a voltmeter and ammeter, power equals V times I, and then energy is power times time. So you have to explicitly say that you're doing that. So you'll want to actually probably even mention that you're going to wait until your voltage and your current are constant before you even start recording data. And it's fine as long as you are, like, right, it doesn't matter what temperature you're at. In fact, if you waited for it to start heating up a little bit before you started recording information, then you wouldn't have to worry about this straight line part, because this is as the thermal energy starts to conduct through the aluminum block, and then when it's all through the aluminum block, we start to get a uniform increase in temperature. Okay. And 3.3. Methods used to determine the specific heat capacity may give a value greater than the actual value. Explain why. It is not because of human error. Okay, just no. Okay, the reason for it is that some energy is transferred from the block to the surroundings. Even if it's insulated, your block, then it will still transfer some energy to the surroundings. So more energy is needed to get a temperature change. Therefore, your SHC will be larger than expected. Okay, so it's about the fact that energy is being transferred from the block to the surroundings. So if there's more energy, which means that you need to pump in that extra energy in order to actually get the temperature change that you expect. All right, that's question 3.